So dear students, so now we are going to learn some integration formula. So from differentiation, we know that d by dx of x to the power of n is equal to n into x to the power of n minus 1. D by dx of k into u, that's equal to k into du by dx. Here k is the constant and u is the function in x. Okay. Now, so in d by dx of x to the power of psi n plus 1 by psi plus 1, this is equal to, here 1 plus n, 1 by n plus 1 is the constant. I take this one outside and differentiate x to the power of n plus 1. That is d by dx of x to the power of n plus 1. So this is equal to 1 by n plus 1. Applying this formula, d by dx of x to the power of n into x to the power of n minus 1. That means n plus 1 into x to the power of n plus 1 minus 1. Here n is not equal to minus 1. So n plus 1 gets cancelled. 1 is also gets cancelled. This is equal to x to the power of n. Okay. So d by dx of x to the power of n plus 1 by n plus 1 is equal to what? X to the power of n. So integrating, so what will get? So integral of x to the power of n dx is equal to x to the power of n plus 1 by n plus 1 plus constant. Here n is not equal to minus 1. So what is the formula of integral of x to the power of n dx? So x to the power of n plus 1 by n plus 1 plus c. Here n is not equal to minus 1. So in this formula, we put n is equal to 0. Okay, put n is equal to 0. What will get? The integral of x to the power of 0 dx. This is equal to x to the power of 0 plus 1 by 0 plus 1 plus constant. Okay, so x to the power of 0, that's equal to 1. Here x is not equal to 0. So this is equal to integral of 1 into dx. This is equal to x to the power of 0 plus 1, that is x by 1, that is x plus c. Okay, so what is the formula of integral of 1 dx? So this is integral of 1 dx is equal to, so x plus c. This is another formula. So next one. So d by dx of, so e power x is equal to e power x. So integrating e power x, what will get? We back this function, that is, so e to the power of x plus constant. So what is the formula of integral of e power x dx? This is equal to e power of x plus c. D by dx of e power x by log a base c. So 1 by log a base is a constant. I take this one outside and differentiate a power x. What is the formula of d by dx of a power x? So a power x into log a base c. So log a base c gets cancelled. That's equal to a power x. Here, so a should be greater than 1 and so a is greater than 0 and a is not equal to 1 because the domain of the log function is always positive real numbers. So integrating a power x, what will get? So integral of a power x dx is equal to a power x by log a bc plus constant. Similarly, we can easily prove integral of 1 by x dx is equal to log of modulus of x plus constant. X should not equal to 0. Right. So we know that d by dx of minus cos x. This is equal to minus, I take minus 1 is a outside and differentiate cos x. D by dx of cos x is what? Minus sin x. Minus into minus, that is plus. This is equal to sin x. Now integrating sin x, we get minus cos x. So integral of sin x dx is minus cos x plus c. Similarly, integral of cos x dx is equal to sin x plus c. So for both these functions, x is belongs to R. Okay, right. So d by dx of tan x is equal to secant square x. D by dx of tan x is equal to secant square x. So integrating secant x, we get tan x plus constant. Here x is belongs to R minus 2n plus 1 into pi by 2, where n is an integer. N is belongs to I. Okay. So similarly, integral of cosecant square x dx, this is equal to minus cot x plus c. Here x is belongs to set of R minus n pi, n is belongs to z. So integral of secant x tan x dx is equal to secant x plus c. Here domain is R minus set of 2n plus 1 into pi by 2, where n is belongs to z. So integral of cosecant x cot x, this is equal to minus cosecant x plus c. So here the domain is, that is x is belongs to set of R minus n pi, where n is an integer. Okay. So we will learn some more formulae in next class. Okay. Thank you.